All right, we're going to continue on in section 5.2 of the Intermediate Algebra book, starting with example 6 on page 184 of your textbook. All right, example 6 reviews for you some of the exponent rules, starting with letter A, x to the 1/2 power raised to the 1/3 power. Now, when you have exponents being raised to exponents, this is what we call the power rule. These exponents need to be multiplied. So the result here will be x to the 1/2 times 1/3. And if you remember your fraction rules, top times top, bottom times bottom when you multiply fractions. And so this fraction here turns out to be x to the 1/6. Letter B says x to the 1/4 times x to the 7/4. Now this is different from the one above because this is a multiplication between two different terms. This is one term with a power raised to a power. So when you multiply the same variable, you add the exponents. So this is going to turn out to be x to the 1/4 plus 7/4. And of course, if you remember your fraction rules, when you add these exponents, you only add the numerators. The denominator stays the same. So this is going to be, 8. Why is that like that? All right, x to the 8/4. Now, of course, whenever you have a fraction, even when it's being used in the exponent, you need to simplify this fraction. So when you divide this or reduce it, 8/4 is actually 2. So this is x squared. In letter C, we have x to the 1/5 times x to the 1/3. This is the same example, same type of question as above in letter B. A multiplication between two terms means we add these exponents. So this is going to turn out to be x to the 1/5 plus 1/3. Now, I'm sure that you guys all remember when you add exponents, they have to have the same denominator. So the common denominator for 5 and 3 is 15. So we're going to change these two denominators of 15 so we can add them. To change denominators, you multiply. 5 times 3 makes 15, so we're going to do 1 times 3, giving us 3 on the top. 3 times 5 makes 15, so we're going to do 1 times 5 on the top, which gives us 5. And then we can add them. That gives us x to the 8/15. For letter D, we have x to the 1/4 over, or divided by, x to the 3/4. When we have a division of the same variable, we subtract. When you multiply the same variable, you add the exponents. When you divide, you subtract the exponents. So this is going to turn into x to the 1/4 minus 3/4. And of course, 1/4 minus 3/4 is going to be a negative amount because the 3/4 is bigger. So So that gives us x to the negative 2/4. And when we simplify negative 2/4, we get x to the negative 1/2. And here's another rule. If you remember what a negative exponent means, it means the reciprocal. So this base needs to go down into the denominator. That's going to turn into 1 over x to the 1/2 power. So a negative exponent means to put your base in its reciprocal. And since right now it's in the top of a fraction, its reciprocal would be in the bottom. Okay, letter E for this example says the cubed root of x times the 4th root of x. So it turns out that we can't multiply radicals that have different indexes. So what we're going to need to do is we're going to need to turn these radicals into bases with fractional exponents. So this will turn into a base of x with an exponent of 1/3 times a base of x with an exponent of 1/4. And then we're back to the same rule again, where if you multiply the same base, you add the exponents. But to add these exponents, they have to have the same denominator. So this is going to turn into, the common denominator is 12, by the way, for 3 and 4. All right, so to turn 1/3 to 12, let's multiply 3 times 4 makes 12, so 1 times 4 makes 4. 4 times 3 makes 12, so 1 times 3 makes 3. And this turns into x to the 7/12. But since we started with radicals, we're going to change this back to a radical to give our answer in a radical form. That would be, let's see, the index is the denominator, the numerator is an exponent. So that would be with an index of 12, x to the 7th power. At the top of the next page, we have example F. The cubed root of 5 divided by the square root of 5. And it turns out, same thing here, you can't divide if the indexes are different. So we're going to change these to bases that have fractional exponents. So the base is going to be 5, the exponent here to the 1/3. The base here again is 5, the exponent is 1/2, because this index in here is implied to be 2, so this makes an exponent 1/2. When you divide the same base, you subtract these exponents. So this is going to turn into 5 to the 1/3 minus. To subtract those exponents, they need to have a common denominator. The common denominator for 3 and 2 is 6. So we're going to change these to a common denominator of 6. 3 times 2 makes 6, so this will be a 2 here. This will be a 3 here. That makes 5 to the negative 1/6. When you have a negative exponent, again, that means that you have to put this base in its reciprocal. The reciprocal of 5 is 1 over 5. So this will be 1 over 5 to the 1/6 power, which is the 6th root of 5. All right, we're going to move on to example 7, which is on page 185 of your textbook. We're going to multiply using exponent rules with fractional exponents. So letter A says x to the 1/2 power times x to the 3/2 plus x to the 4th. Now, when you multiply like this, you're multiplying the same base together. When you multiply the same base, you add the exponents. So this is distributive property. We're going to multiply this term times here, and then this term times here. And when you do that, you add the exponents. So that's going to turn into x to the 1/2 plus 3/2 and then that's this times this, and then there's a plus sign here, so we need a plus, and again, x to the 1/2 plus 4. So you can see that when I multiply this times this, I add these exponents. When I multiply this times this, I add these exponents. Exponents need to have a common denominator, which these do. So this is going to turn into x to the 4/2, which is x squared, 4 divided by 2. These are a little bit more difficult to add, but if you know the rules for adding, 1/2 plus 4 makes 1.5, 4.5. So this is really x to the 4.5, but we're not going to use a mixed number. We're going to change that to improper fraction. So 2 times 4 is 8, plus 1 is 9. This would be 9/2. So we end up with x squared plus x to the 9/2. And you cannot add those two terms, because you can only add like terms, and like terms have the same exact exponent, so these cannot be added because they are not like terms. Okay. All right, letter B says x to the 1/3 times x to the 4/3 minus 2x plus x to the 5th. This is the same rules. When you multiply this times this, you're going to add these exponents, and this is distribute, so you're going to do that 3 times. So we're going to get x to the 1/3 plus 4/3, and I'm just going to write all this out, then I'll go back and simplify it, minus, all right, when I multiply this times this, I have a 2 coefficient, so I don't want to forget about that. 2, and then the x's, 1/3 plus, there's a 1 here, do not forget about that 1. So 1/3 plus 1, plus x to the 1/3 plus 5. Right, so I multiplied here times here, and I added these exponents, then here times here, and I added 1/3 plus 1, then here times here, and I add 1/3 plus 5. And then I'm going to simplify all these exponents here. 1/3 plus 4/3 makes 5/3, and that's fine. 1/3 plus 1 is 1 1/3. When I change it to an improper fraction, I get 4/3 plus 1/3 plus 5 is 5 1/3. When I change it to an improper fraction, I get 16/3. Now, I know you're going to be tempted to add these all together because they have the same denominator, but to be like terms, they have to have the same exact exponent. And because these numerators are different, these exponents are not equal. So this is complete now. This is your final answer. For letter C, we have x to the 4/5, which 4 minus 2 times x to the 4 fifths minus 1. All right, we have a binomial times a binomial, which we're going to use double distribute or FOIL. So we have to multiply this times this, then this times this, then this times this, and this times this. So 4 different multiplications. We're going to write those multiplications out and then simplify the exponents. So first this term times this term, and that will give us x to the 4 fifths plus 4 fifths. Multiply. When you multiply, you add exponents. And then this times this gives us negative 1 times x to the 4 fifths. And this times this gives us negative 2 times x to the 4 fifths. And then this times this, negative 2 times negative 1, gives us positive 2. Now we can simplify a little bit. 4 fifths plus 4 fifths makes 8 fifths. So x to the 8 fifths. These are like terms because their exponents are identical. So to add these like terms, we add the coefficients. Negative 1 plus negative 2 makes negative 3. So negative 3 x to the 4 fifths, and then we just have the plus 2 at the end. You cannot add these two terms because the numerators are not the same. Exponents have to be identical for you to be able to add them. 1/2. 5. All right, moving on to example 8, which is on page 185 of your textbook. We're going to do some factoring with fractional exponents, and yes, this is challenging. So letter A says 2x to the negative 1/3 plus 5x to the 4/3. All right, so factoring is the opposite of multiplying. It's breaking apart the multiplication. So what we're going to do, the end result should look like something that should be distributed to be simplified. It's the opposite of simplifying. When you factor with fractional exponents, you just look at the exponents and you choose the one that is the lowest value. So which one is less, negative 1/3 or 4/3? Well, obviously, negative 1/3 is a lower value. So that's what you're going to factor out. You're going to factor out an x to the negative 1/3 power. And then you undo the distributive property that makes this term. Or in other words, this times what gives me this. So of course, if I divide by this times something to give me this would have to be the 2. And of course, you're going to check it by doing some mental multiplication. If I multiply this times this, I get this back. Okay, good. Then the plus sign. I need a 5 to get that 5 back from up here. So I'm going to have this times a 5. Now, the challenging part is the x. So you have to think about, all right, what exponent belongs here so that when I add 1/3, negative 1/3, plus this to give me 4/3. You can find it by subtracting 4/3 minus, not minus 1/3, minus negative 1/3. So you can find that by subtraction. 4/3 minus negative 1/3. Or, in other words, take the exponent you have up here and subtract whatever exponent you're factoring out. If you know your rules for signed numbers, you know this turns into a plus. So 4/3 plus 1/3 makes 5/3. And that's your factored form right there. Letter B. Let's move this up a little bit. All right, letter B says x to the 2/9 minus x to the 7/9. And we're going to use the same rule we did before. Look at your exponent, choose the smaller one. Well, 2/9 is smaller than 7/9, so that's what I'm going to factor out. 2/9. I'm going to factor out x to the 2/9. What do I have left? Well, thinking about multiplying, I would like to erase that now. Shouldn't have put that there. Thinking about multiplying, this times this has to make this. So I already have the whole thing. They match. So how am I going to get that back? Is just by multiplying times 1. If you factor out a whole entire term, you just multiply times 1 to get it back. To get this term back, remember you do subtraction. So you can subtract 7/9 minus 2/9, and that gives you 5/9. And that's your factor form. For letter C, we have 1/2 x to the negative 2/5 plus 3x to the 3/5 minus 1/7 x to the negative 1/5. All right, don't stress these coefficients because they don't really have a common factor, so you're not going to really factor out anything from the coefficients. Looking at the exponents, choose the smallest one. Well, these two are negative, so obviously they're smaller than this positive one. Which is smaller, negative 2/5 or negative 1/5? And if you remember your rules for negative numbers, the negative 2/5 would be further to the left, so this would be smaller. So that's the one we're going to factor out. We're going to factor out x to the negative 2/5. So this times this has to give us this back. Well, we need the coefficient, so we're going to need the 1/2. We factored out the entire exponent here, so we don't need anything else here. If I multiply this times this, it will give me all of this back, so we're good there. We need a plus sign. From the next term, we need the coefficient of 3. We're going to need something from this variable, and if you remember the rule, you're going to subtract 3/5 minus negative 2/5 or plus, since this is a negative. 3/5 plus 2/5 makes 5/5. So this will be 5/5. Then a negative sign, then the coefficient again, and the x, we might need to actually write this one out since we have two negative numbers here. We're going to do negative 1/5 minus negative 2/5. So I'm going to write it. Where am I going to write it? Down here. Negative 1/5 minus negative 2/5. These turn into plus, so they are different signs. So basically that means you have to subtract and take the sign of the larger one. So that would be a positive 1/5. So this is going to turn into positive 1/5. And that's the factored form.